Hey everyone, I wanted to show you the 2004 problems. Uh, the solution guide's on your Haiku, or just Google it. Remember I told you to Google something like 2004 AP Test Solution Manual. These are the three problems from the first Haiku that I gave you from 2004. So the first one is a calculator problem. So you can look at the picture. It's the graphing calculator problem number 2. And we did parts A and B in class, but we didn't do part C. Part A is pretty traditional. Again, the area of the region is subtracting the f of x minus g of x. Don't forget the dx. You can also type in or write in the original function, f of x minus g of x dx. And if you use your calculator, remember 3 decimal places rounded or truncated, 1.133, and the square units are assumed. Letter B, you're rotating the region around y equals 2. So this is the volume around y equals 2. And the tricky part with this question is the outer is 2 minus g of x, and the inner is 2 minus f of x. Now if you look at the picture, the f of x you'll see, because remember, the region looks something like this, all right? But the g of x is below the x-axis. So here's y equals 2. So if I essentially flip it about the x-axis, that's why the region is 2 minus g of x. That's what makes it a little bit tricky. And then the 2 minus f of x is going to be the difference between where f of x is and y equals 2. Again, you can write it out, but don't forget the outer squared minus the inner squared dx. And I found this to be very tricky to type this out. But if you do type it out, you will get 5.150. Don't forget the 0, even though it's a third decimal place, and then put the pi in. That would be my suggestion. And again, cubic units are assumed. Letter C is a little tricky. The cross-section that's perpendicular to the x-axis is a square. The h of x is given in the problem. Again, refer to the question. So the area of the cross-section is h of x minus g of x squared. That's because it's a square. Remember, no pi. So the volume is going to be equal to the integral from 0 to 1 of h of x minus g of x squared dx. And you're essentially just going to set that equal to 15. Again, you're not finding the answer, you're just making an equation with an integral, and that would be the answer here. And again, I just replaced h of x with g of with the actual answer. So that's kind of a neat problem, and I thought that was a really good way to answer letter C. And again, you can consult the solution manual, all right? Question 4 from 2004 is a no calculator problem, and it's an implicit differentiation problem. Really traditional. So again, the original problem is, on the Haiku, or you can look at the solution manual, etc. So how do you find dy dx? Traditional implicit differentiation. So that might be a nice review. I bring the part that is not attached to dy dx to the one side, and I take the part that is attached to the dy dx to the other side, and I should get the answer that they asked for part A. This is a very traditional question that I would expect people to get right. Question B, again, you can reread the question, but in order for the horizontal slope to occur, the numerator has to equal 0. So I'm setting the numerator equal to 0. I know that x is 3, because that's what they tell me in the question. Solve for y. So that's not too bad. All right? So the ordered pair where there's a horizontal tangent is 3, 2. Part C, they want you to evaluate. Remember, evaluate the second derivative. So use the quotient rule. Again, look at my notes here. Use the quotient rule to find the second derivative, but don't simplify the second derivative. Don't substitute this whole thing in for dy dx. That's going to put you in a tremendous wave of just not getting the answer correct. A terrible loop. Keep it in this form. but use the quotient rule to set up the second derivative, and then I just replace. So I'm going to put 3 for x, and I'm going to put 2 for y, and for dy dx I'm going to put 0, because I know that the slope at 3, 2 is 0 from the previous question. Substitute, so I'm substituting here, and just look at my math. Again, slow it down however you wish, but eventually your answer turns to negative 2/7. So that's going to be a big part of this problem. But then they say, is 3, 2 going to be a relative max or a relative min, or neither? And the way to answer that question is that back pocket concept of the second derivative test. If you recall, the second derivative test says that if the dy dx is 0, but in this case the second derivative is negative, then it's going to be a local max. Should the second derivative have been positive, then by the second derivative test the curve would have a local min at this point. That's something that I kind of told you to put in your back pocket. That's a very rare question, but we will review the second derivative test before May 12th. Okay? Let's take a look at number 5, which I thought was probably the easiest of the three. I think so at least. And if you notice, this is a very traditional fundamental theorem of integral calculus questions. So if you look at the graph, again, you have the graph in front of you, but g of 0 is going to be the integral from negative 3 to 0 of f of t dt, which turns out to be 4.5 or 9/2. G prime of 0 is equal to f of 0, which is equal to 1 if you look at the graph of f. So I thought that was a pretty easy question. Letter B, there's a relative max at x equals 3 because the graph of f is above the x-axis when x is less than 3 and below the x-axis when x is greater than 3. It's the only x value where g prime equals f when the graph changes from positive to negative. However you want to write it, again, the APs expect a very succinct, solid statement or sentence to justify your answer. Again, pretty traditional here. Letter C, I thought was probably the trickiest of the four. Where's the absolute min? Now, remember, with absolute mins, you have to test the endpoints, okay? G of negative 3 is 0 because the integral from negative 3 to negative 3 of f of t dt is 0. We know that, okay? So if you look at the graph, it's always above the x-axis from negative 3 to 3, right? And so that means it's increasing. And then between 3 and 4, the graph goes down a little bit. Again, consult your problem. You'll see that. So imagine a graph increasing a lot, then decreasing a little. That's not going to be an absolute min. So then go to the left, and you'll realize that g of negative 4 is negative 1. Because the area of the triangle is above the x-axis, but you deem it negative because you're going backwards in integration. Your lower limit is greater than the upper limit. And g of negative 5 is 0 because essentially the two triangles will cancel each other out. So the absolute min has to be at x equals negative 4. But the question specifically says, what is the minimum value? And, statistically, a lot of kids get this question wrong because they don't find the y-coordinate here. The y-coordinate's negative 1. That's the answer that they're looking for this question. Letter D is a home run question, and just because it's letter D doesn't mean that it's going to be a hard question. In this case, where are the points of inflection in the graph of G? And we know that if you look at the graph of f, a point of inflection is going to occur when the slope changes from positive to negative or vice versa, okay? So looking at the f graph, you will see that the x-coordinates are negative 3, 1, and 2. And that's pretty much it. Tomorrow I'm going to show you the 2005 problems. And, chat with me tomorrow morning if you have any questions. Thanks.